Okay, when the person makes a jump, okay, when this person makes a jump here, so he's going to make a jump. There's a person, then he will jump with a velocity u r relative to the trolley. There's the thing. Why the trolley should recoil back? There's some sort of like a force will act here. That particular force we'll call a thrust force. Then why do that thrust force will come? Due to ur dm by dt. This will come in variable mass concept. When we go for there in detail, it'll be like this. So now mass of system decreasing. So substitute dm by dt with sign plus or minus dm by dt. Here, look at this. What is the mass of system? M plus 3m initially. Trolley you can call as system B. Trolley as system B. What is the initial mass of system? M plus 3m 4m. Now, what is the system? The trolley is the system. Now, there's some mass ejected. No? So if the mass ejected, mass of system decreases minus dm by dt. So look at what is the direction of the person will make a jump, and what is your velocity of the person relative to trolley. So therefore, some sort of a thrust force will act here. So this is called like a thrust. Later, variable mass concept there we'll discuss in detail. Now time being, just have only this much of idea. So therefore, a thrust force will act on the trolley, that one. Because of the thrust force, so what will happen to the trolley will recoil back here. So here I'll put a velocity of trolley. What is the velocity of person? Velocity of person will be v1. We don't know, that we have to calculate. And now what is the net force acting on system? The same thrust force should act on the person. The same thrust force. So now don't bother anything. Just equal and opposite force will be acting on the person and the trolley. Time being, only have this much of idea. Now, what is the net force acting on system along x-axis? 0. So therefore, initial momentum should be equal to final momentum. Initial momentum should be equal to final momentum. What is initial momentum? They are at rest. Finally, mv1 minus 3mv2. So now both are unknown. No? So I'll take help of this one. Anything directed towards right, positive. So plus ur is equal to velocity of person plus v1 minus v2. Why negative sign here? Why negative signs? Try to see that signs here. Velocity of trolley will be towards left, so therefore will be negative. So what is the value of ur now? ur minus v2 should be equal to v1. Let me eliminate v1. M into ur minus v2 3m v2. mur by m plus 3m. So this will be ur by 4. This is the velocity of trolley. Recoil, speed of the trolley, recoil speed of trolley. Already that sign I taken care in the formula, and also I'm showing in the diagram. It will be towards left. Whatever the velocity of person, how to calculate? So substitute that value of v2 here. You will get the velocity of person. So ur v2 is how much? ur by 4 equal to v1. So what is v1 equal to? 3 ur by 4. There's a one very basic thing. From where this, look at the energy for the person is having kinetic energy, mv1 square. Look at the trolley. It's also having 3mv2 square by 2. From where this energy has come? Work done by the person. Work energy theorem. Work done equal change in kinetic energy. But sir, what about thrust force? Thrust force are acting. Internal forces can do work, no? I think in workmanship chapter, we have come across the internal forces can do work. Work done by internal forces can be non-zero. But due to internal forces, what will happen to momentum will be conserved. So internal forces can do work. So what is Ft now? Ft will become internal force. This will become an internal force to the system. To this trolley blocks man system, that will become internal. So internal forces can do work. But altogether, this energy, this internal force, what it did positive work on the person. It did positive work on the trolley. Not like network, the internal force is zero. Then what is work done by person means change in kinetic